Great. Okay, let's look at names and formulas again. Do you have a periodic table with you? Please take your periodic table. And I'm just going to do the following. Just do a little revision of what we've done. Okay, there's the periodic table. Now, I want to know what is the charge by using the periodic table. What would the charge of the following atoms be once they become ions? Let's start with sodium. A sodium atom, if that becomes an ion, what will the charge be? You have to find sodium on your periodic table, look in the group number it's got, and then give me the charge. Can anyone do that? If Zelna or Calvin wants to answer, then they must just unmute themselves. What group is sodium?
Sodium, sodium is group 1.
So the charge on the ion?
Is 1.
Plus 1.
Plus 1.
Yeah, you can't say 1 because 1 can be a negative or a positive. So it's positive 1. Okay. Then I want to know what is the charge on calcium? Calcium.
There's a positive 2 charge.
2 positives. You are allowed to write positive 2 because it's just a charge. You're gonna be working with those 2 pluses. It's going to be important a bit later. Can anyone give me the charge on chlorine? Chlorine is Cl. Anyone?
-1.
-1. Okay, can anyone else answer the next one? I want to know the charge on oxygen ion. O. Let's ask Calvin.
-3.
Nope.
-2, sorry.
-2. 2 negative. No. Awesome. Please look in your textbook. If your textbook has a tendency to write 0, -2, or 2 negative, and calcium +2 or negative or 2 plus. It's kind of important. I just want to give you exactly the same as what your textbook would do. Later on, you'll use the numbers first. I don't want to confuse you because both is correct. There's just the charge value.
So they put the negative or the positive after the number.
Yeah. So the left-hand side is correct. Is what your textbook is using. Is that correct? Please answer me.
Pardon?
Is this side correct? The left hand, not correct. It's what your textbook is using. This side.
Yes. Yes.
Okay. So we're going to do the numbers always first thing, just to be in line with your textbook. Otherwise, you might feel confused later. Awesome. Okay. Now, say for instance, I want to know what is the formula. This is all we did last week. We're going to move from here in a minute. What is the formula for calcium chloride? So that second C must be a small letter. What is the formula for calcium chloride? I didn't have enough space, so I contracted those.
Will it be Ca? No.
Ca?
Ca plus Cl.
Okay.
That then would be.
There. Why would there be a 2 at the bottom of the chlorine? Come. For each calcium, which is 2 plus, I need 2 chlorine ions. Why?
To make it neutral?
Yeah, to make the compound neutral. Because the compound doesn't have a charge. The compound is neutral. Okay, so now we're going to do 3 or 4, and I want you to use your periodic table. Do you have it in front of you? Periodic table?
Yes. Yes.
I want you to do potassium. Let's say bromide. And I want you to do magnesium fluoride. Let's just do the twos. What is potassium on your periodic table?
K.
K. Okay, and charge?
+1.
Excellent.
1 plus.
Yeah. So a single plus, and then bromide.
It's on the periodic table, it's Br.
And charge on the ion?
-1.
-1. So compound, please. K, Br. Just like that. Easy, isn't it?
Yeah.
Magnesium. Magnesium is in which group?
Group 2.
Charge on the ion.
2.
+2.
2 plus.
Oh,
Chloride. Fluorine ions. Come. It's F.
-1.
It's F, -1. Okay. Formula, please. M, G,
F2.
F2. Awesome. Last one. Let's do a difficult one. Aluminium. What? Sulfide. I think it's sulfide in English. There we go. So it's aluminium and sulfur. Aluminium is in what group? Al.
is it in group 3?
Charge.
Negative. I mean,
3
positive
plus.
3 plus.
Awesome. Sulfide is sulfur. Symbol.
Well, symbol is S.
Charge.
-2.
Compound.
Al2 and S3.
Awesome. There's a cheat because you just put that value there and that value there. Okay, good. This is what we did last week. We are going to now just make it slightly harder by using polyatomic ions. Now, this is a list of polyatomic ions that you have to learn. Hydroxide, nitrite, hydrogen carbonate, hydrogen sulfite, okay, etc. Chloride, blah, 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 sulfite, sulfate, chromate, etc. That table you'll find in your textbook. You're going to study this. Why? Because I can ask you, say, for instance, instead of asking lithium chloride, I can ask lithium nitrate. So what does lithium nitrate look like? Now, the problem is nitrate is not on the periodic table. Nitrate is something you studied. So lithium is in the periodic table. Lithium is in group 1. So the ion is +1. And nitrate you studied. There we go. Nitrate is NO3 1-. So how does that look now, Calvin? It's just LiNO3, isn't it?
Okay.
Okay, why? Because lithium is a +1 and nitrate is a -1, so they bond. It's called an ionic bond. They bond with, and the substance is neutral. But if I had lithium, say for instance, what? Sulfite. Instead of nitrate, I had sulfite. Now sulfite, you learned. It's SO3, or you are going to learn 2-. What would that compound look like?
LR2 and SO3,
Bang.
2 negative.
The 2 negative is not going to go with. The 2 negative
yeah.
will give you the charge. So that is lithium sulfite. Okay, these things are important. Otherwise, we can't write chemical equations. So you're going to find that part in your textbook. You're going to be studying. Next week, you must be able to know how to use the periodic table to get the charges of elements. Then you must be able to mix elements together with their charges like we did today and last week. And you have to put certain elements or the ions of certain elements. You have to add to polyatomic ions. Polyatomic ions, you get a list that you have to learn. Now, there's one more thing that we have to do. One more thing. Okay. Now, look at the metals in the middle of that table that we haven't spoken about. I'm just going to enlarge this periodic table or go back to the previous one and copy that one. I'm just going to copy this. Now look at this. These are called transition metals. And if you look at these group numbers here, there's a group 2, and then you'll see there's a big jump to group 3. Now all these metals here are called transition metals. We don't know what their charges are. Like, look at one of the most popular ones, Fe. Who can tell me what Fe is?
Iron.
Iron. Iron. Now, what is the charge of iron? Well, we don't know. We don't know. So if we want to write a compound with iron in it, like say, for instance, iron chloride, I can't write iron chloride. I must write iron 2 chloride. Is chlorine. But chloride is the iron. Okay, chlorine will be on your periodic table, but chloride just means it's the ion of chlorine. Okay, now this is actually very easy because I'm actually telling you what the charge is on iron. Now, iron is a metal. All of these are metals. They all have positive charges. So iron is 2+. Why? Well, I've given you that 2 value. Because iron can be 1+, 2+, or 3+, depends on how it bonds. But you won't know that, so I'm giving you the value. They'll give you the value. Iron is 2+, and chloride is -1. So you would agree with me, it is FeCl2. Easy. Okay?
Yeah.
Good. So if I give you the following, if I give you, let's say, iron 3 oxide, what would that formula look like? Anyone?
FeCl. No.
Would it be Fe +3?
Okay, let's get the ions first. Iron is Fe3+, no? And oxide, O2-, because oxygen is 6. So what would the formula look like?
Fe2O3.
O3. Okay. So once you've learned that list, then you'll be able to do something like what? Let's look at the list. Can you see this list, or is it too small? It's too small.
It's big enough.
Okay. So now I want to know. You're going to try and do this one. I want to know what is copper to manganate. What does copper to manganate look like? Get the ion of copper, get manganate from the table. Remember, you must still learn that table, and then we answer the questions. Then we're going to do something new that's really easy, and it's important for this term and for your task that you have to do. I'm also here to help you with your task. Once you get the task and you've got questions, I can help you. Anyone who's not spoken yet? What about Zelna? I didn't hear your voice, Zelna.
It's me.
Oh, and then it's Saskia that I haven't heard. Saskia, speak up.
What
What's copper? Copper is Cu, no?
Oh.
Yes, see.
Charge.
Will it be
I've sort of given the answer already there.
will it be 3 plus?
No, no, no. Those are two lines. So it's 2 plus.
Oh, so it'll be 2
Yeah, the lines there gives you the answer. And manganate, you have to find manganate on the table.
is
MnO4 2 negative.
oh
Here's manganate. Once you've tattooed that table on your arm, then you'll do well in the exam.
oh now I get it.
Yeah. Answer CuMnO4. Done.
Oh,
Last one. Right. Now I want to show you something. What you need to know, find quickly is hydroxide. And I want to know what is, let's do calcium. Calcium is very important. Hydroxide. What is the formula for calcium hydroxide? Calcium you'll find somewhere in group 2. Calcium is what?
it's Ca
Ca. Charge.
and 2 plus.
Hydroxide. OH. Come. It's on the table.
H.
OH and positive 1 charge.
No. That's why a cell phone doesn't work very well.
Okay, do we use the negatives? So we use the positives or negatives with the sign on the thing.
I didn't get that. Say again.
So we will, if there's a negative on the table, you provided us, and we use that sign. And the
Yeah.
sign we think is on the.
Yeah. Look, hydroxide is not the same as hydrogen. This is hydroxide and this is hydrogen. Hydroxide is an oxygen and hydrogen attached to one another. It's quite easy to get the charge for hydroxide. Look, oxygen is 2 negative and hydrogen is 1 plus. If they come together, then the net charge will be -1, isn't it? So hydroxide is -1. So now give me the formula here. And I'm going to try Kelvin again. Someone is hiding, which I name I can't see. Aisha. Aisha. Where are you?
Akiva.
It's Akifa.
But I've got a K in there and an S. Just say that. Just spell the name. I've written it down. wrong. Yeah.
K-I-F-A-H.
Ah, okay. I've got an S there instead of an F. I'm really sorry. That's why I cannot get your name right. Akifa. That's a very interesting name. What does it mean?
Lady who worships God in solitude.
Oh, wow. That's awesome. Wow. My name doesn't mean that. Okay. Right. Okay. So what would the formula be? Ca. And then look here. I need 2 hydroxides. Do you agree? To balance that +2 charge. So I'm going to do this. OH in brackets 2. Why? I cannot write CaOH2. That means I'm only putting 2 hydrogens there, not 2 oxygens. So I have to put that in brackets and a 2 at the bottom so that both the oxygen and the hydrogen is multiplied by 2. Do you understand that? That's like very important. Happy?
Yeah.
Okay. Right. We're going to stop here. We're going to do this type of work throughout the term. Wherever we have a 5 minute or 7 minutes left of any class, we're going to play around with these things because they are very important. Okay, now we're going to start a little section on work that you're going to do an assignment on, which is going to count, I think, 50 marks for the term. It's really important. And that is the kinetic model of matter. It's really easy. And I think most of you understand this already because you've played with something like water. You've put ice in a cool drink. You've actually seen maybe some snow. You've actually played around willingly or unwillingly with something like water. So there are 3 different phases. I'm going to use water as an example for now. You're going to also do experiment with water. The water can be in a gas phase. Do you agree? What's that called?
Yeah.
There's a specific word for that. It's called water vapor. Right. If you boil a kettle and there's like, maybe you call it steam. There's steam that comes off. It's actually water molecules, but it's in gas form. Then water can also be a liquid that we all know because we drink that daily. And water can also be a solid. And that's in a form of ice. What is important is that you must also be able to explain why is the density of a solid water, in other words, ice, why is it lower than the liquid form? Your textbooks can explain that to you. Very important. Most substances, in fact, I can't think of any other substance, but let's say 99% of all substances, the density of the solid state is higher than the liquid state. So whatever, if you take any other liquid and you make a solid of that liquid and you put them together, then the solid will sink down to the bottom because its density is higher. While water, once you freeze water, the density becomes lower and it raises up. So that's why when a lake freezes over, the ice is on top, not at the bottom. So there's a lake in Siberia. It's huge. I think it's 17 or 18 kilometers long, just the one side. And that freezes over in winter, and you can go and ice skate on that. It's a big thing. It's like, the whole lake is bigger than Cape Town and its surrounding areas. So that lake, you can skate and do sport on that whole lake because ice is actually moved up and formed at the top of the lake. You have to be able to explain that. Okay, then the other things that you have to know is these words. If gas becomes a liquid, it's called condensation. If a liquid becomes a solid, it's called freezing, but that's kind of obvious. If a liquid boils and forms a gas, it's called boiling. If a solid melts and becomes a liquid, that process is called melting. And then there's 2 new words that you might not know. When something transforms from gas phase directly to solid phase, it's called deposition. Your textbook might use another word there, might. And when it goes directly from a solid to a gas, that's called sublimation. So these are all words that you have to learn because you'll have to use those words in explanation. Okay, I want to see what's the next page is about. Okay, now the kinetic models of matter, or they just call it kinetic model theory. Kinetic model theory tries to explain on a molecular level what happens when those phases change. What happens when something is a solid and becomes a liquid, or when a liquid becomes a gas, or a gas becomes a liquid again? What happens to the molecules? Now, these little bubbles or circles, they represent molecules or atoms. What is the difference between a molecule and an atom? Let's look at hydrogen. That is a hydrogen atom, but a hydrogen atom doesn't occur alone. We're going to learn that quickly in the near future. A hydrogen atom is always connected to another hydrogen atom. So this thing is called atom. And when it's connected to another hydrogen atom, that's called molecule. Molecule. I think you did that last year already. Is it true? Yeah. We spoke about molecules and atoms. It doesn't matter. I'll show you what a water molecule looks like. A water molecule is H2O. It consists of one oxygen that is bound to two hydrogens. That's a water molecule. Now, each one of those circles here represents one of those molecules. So when water is a solid, when it's ice, the molecules are packed densely to one another. Look how dense those molecules are packed. And they just vibrate. They're not moving anywhere. So that solid piece of ice that you've got in your hands, I know you can't feel it, but you should actually, if you're very sensitive, you should actually feel the vibration of those molecules. They're just vibrating. They're tightly packed to one another, forms a crystal lattice. It's a word, a certain way that they connect with one another, and they're just tightly packed. They're not moving. When you heat it up, so we're going to apply and increase the heat. When we increase the heat, the molecules loosen up. So I'm going to show you these two molecules now, those two. There's the one water molecule, and that is the other water molecule. Now those two, the bond between those two molecules, as I increase the heat, I increase the kinetic energy. Let's just talk about this. What is kinetic energy? Kinetic energy is the mass of an object times its velocity square. It's actually half mv square, but you don't have to know that now. You're going to study that later. So as I increase the heat, I increase the movement or the velocity of those molecules. In other words, they start moving very rapidly. They were vibrating when they were solid, and when I heat them up, they start vibrating a lot, and then they loosen up from one another, and they start moving up and down and left to right because their kinetic energy is increased. So heat, which is energy, is what we call directly proportional to kinetic energy. The more heat I put in the system, the higher the kinetic energy will be. If the kinetic energy increases, what will increase? The velocity. Therefore, the velocity, V is velocity, will also increase. Do you understand that? Think, just visualize it. Close your eyes and see there's a lot of molecules connected to one another. If I put a lighter under it or put it in hot water, the bucket, or just put it on a hot stove, those molecules will start vibrating more and more, and then they will loosen up from one another, and then they'll start moving around. Their velocity will be higher because they have more energy. Then the next phase is when it becomes a gas. When it becomes a gas, these bonds between the water molecules break up, and each one of these molecules can then go its own way. They're not attached to one another. The molecule goes its own way, and that molecule goes its own way. So once it becomes a gas, if you look at that water vapor or that steam coming out of the kettle, the steam just goes anywhere. Why? Because the molecules are not connected to one another. They move away from one another. So everything I've said now, they're going to structurize in a little 4 or 5 phrase thing for you, so that you need to be able, for 3 or 4 marks, explain what happens when you heat up water. What happens on molecular level? In other words, use the kinetic molecule theory to explain what happens to the particles. Is that okay?
Yeah.
Okay. Just quickly read that. If you can see on the screen, just read that. That is the type of paragraph that you'll get, that you'll have to learn and explain. And then you give me indication when you are finished. It's fine. Okay. So all you need to be able to do now, you don't have to learn or know it off by heart. You need to be able, chemistry is all about visualizing stuff. You need to be able to visualize what happens to the molecule from a solid to a liquid to a gas and back, obviously. You can also move back from a gas to a solid. So from a gas, the molecules are moving independently from one another. If I cool it down, so the heat goes down, I cool it down, I decrease the kinetic energy. So the molecule starts moving slower as they become cooler. Then at a certain point, they connect again with one another. Then they form a liquid. They're still moving around. They're not vibrating. If I cool it down even more, they move slower. Why? Because when the heat decreases, the kinetic energy decreases. They decrease so much that they come to a standstill and just vibrate next to one another. Okay, now, what we've done here, we're almost finished with this. We must be able to draw on a graph, and you are going to get a lot of this. I'll show you two graphs. This is called a heating graph. So let's go over this graph. Right at the beginning, our substance is a solid. So at 30 degrees Celsius, we have a solid. Then I increase the temperature. Can you see that as that graph increases there, the temperature increases to about what, 55 or something? If you take a guess there, just under 60. I don't know if they're counting in 2s or 5s. Doesn't matter. Okay, no, it does matter. Let's try and get that exact figure. I'm assuming, how many blocks do we have between 30 and 60? Like 1, 2, 3, 4, 5, 6. So that's in 5s. So that is 55 degrees just there. Do you agree with me? Hello.
Yeah.
Okay. So we have a solid at the beginning at a low temperature, a solid. So what happens between 30 and 55 degrees? As the temperature increases, the kinetic energy of the molecules increases up to 55 degrees Celsius. Then we have a flat part of the curve. This flat part of the curve indicates that there's a change in phase. What phase change do you think will occur? What will the object or the substance be after that? It will be a liquid, isn't it? After a solid. So from at 55 degrees, so 55 degrees Celsius is its melting point. Do you agree? It moves from a solid to a liquid. Now, very important, there is no change in kinetic energy in this part here. The kinetic energy doesn't change. So what happens? If you take ice, a bucket of ice, and you put it on a hot plate, it starts to melt at a certain temperature. Okay, let's assume it's 55 degrees. The molecules won't move faster. The kinetic energy of the molecules won't increase until all the ice is melted. Why? Because the ice that is not melted yet cools down the liquid all the time until all the ice is melted. So for that whole time period, that flat part of the line, which is now yellow, the kinetic energy doesn't change. Then suddenly, when all the ice is melted, the kinetic energy increases again. And it's now a liquid. This substance is now a liquid. This is probably an alcohol or something. This is not the curve for water, because we know that water changes phase at 0 degrees Celsius, not at 55. Okay, now that blue section is when this substance is a liquid. Again, the temperature increases. How can we see that? Well, it's changing from 55 to 85. Yeah. Oh, it's 90. Sorry. Let me get that bit bigger. That's 90 degrees Celsius. So at 90 degrees Celsius, there's a change in phase again. So there's another change in phase. So what happens here? The kinetic energy stays constant. Your book might say that the potential energy increases, but I think they've taken that out of the books. It's not wrong. It's just not necessary. So there's another phase change. And after that, this will be a gas. So after 90 degrees Celsius, at 90 degrees, the phase changes from a liquid to a gas. This is really easy, isn't it? All you need to know or understand is that kinetic model. Otherwise, you'll struggle to explain what happened. You'll know when it's a solid, liquid, gas, but you won't be able to explain this for marks. Good. So look at this one. This is called a cooling curve. The other one was a heating curve. This is a cooling. Why is it cooling? Well, it goes from 160 degrees to 20 degrees. So the temperature is decreasing. That's why it's cooling. Can anyone tell me what is happening at this first blue part here? So what we know is that every line that is parallel to the x-axis is a phase change. And any line that is got a gradient there is a specific phase. Who can tell me what the first phase would be?
Gas.
Sorry?
A gas.
No, it will not be a gas. It will not be a gas at a higher temperature than this part. The higher the temperature, the gas is always at a higher temperature and the solid's always at a lower temperature. So this is a cooling curve. So it will start as a gas. So this substance is a gas there. Then it changes phase and becomes, what is the next blue section?
Liquid.
Liquid. Good. And then the last section, solid. So cooling curves, you move from a gas to a liquid and a solid. Okay, now I've got following questions. I want to know, one, what is its, let's make it difficult, melting point? And number two, what is its boiling point? Okay, what is melting point? Melting point is when a liquid becomes a gas, and boiling point is when a solid becomes a liquid. Melting point is when a solid becomes a liquid, or the temperature between the solid and the liquid, and boiling point is when liquid becomes gas. Who can tell me the melting point of that substance?
Would it be 70 degrees?
70 is correct, degrees Celsius. Just always remember to give the, they've given the degrees Celsius, but we're going to work in Kelvin also. It's just another way to indicate temperature. Boiling point.
120.
120 degrees Celsius. Awesome. All right. Okay. So if this, let's assume that this substance is at 10 degrees Celsius. What state would it be?
Solid.
Yes. Solid. Is this difficult? It's extremely difficult. No, this is quite easy. All you need to know is the difference between a cooling and a what? Liquid. Okay, now look at this. They might try and make it very difficult for you. They might do this. They might give you a curve that's only got 2 sections in it. Something like that. And then they're going to give solid here and gas here. Well, this is quite interesting. So I'm going to just do values here. Let's say 70 degrees Celsius. And I'm going to do, yeah, just that. Okay, first thing, is this a heating or cooling curve?
Cooling.
Awesome. It's cooling. Temperature is going down. Okay, I don't have another temperature in here, but I could have made a temperature there of, say, for instance, 30 degrees Celsius. Doesn't matter. Right? Okay. What is the state? What is this phase change here? So what is the change at 70 degrees Celsius? It goes from a gas to a solid.
Disposition.
Let's find that. There's a specific word for it. Let's find it here. From a gas to a solid is what?
Sublimation.
No, sublimation
No,
is solid to gas.
sublimation.
And gas to solid is deposition. See, quickly go to your textbook because I want to just test that name. I think deposition is an old term. Quickly go to your textbook and you'll find those curves there. They'll and just in front of that, they'll give you the terms. So I want to see if they still use the word deposition. Oh, this is a common word, but I just want to make sure they're still using that word. So I have it as deposition. It's when a gas transforms to a solid without going through the liquid phase. Can you find it?
Yes.
Nope. Okay. Well, deposition is right. Just want to make sure your textbook. You can just look at that deposition. Is it a T or a S? It's a T.
I think it's right.
Yeah, I think it's right too. It's just I was just under the impression that they've changed it recently and used another word. That's what it's always been. Okay. Do we have examples of that? Yeah.
No, wait. Yes, in our books, they have an example of I think yeah, it's a boiling heating curve, and then we have an activity.
Deposition happens when water vapor becomes ice instantly.
Yes, yes, we do have an example.
That's what we're going to use water. You're going to use water as an example also. Okay, now this basically is what this chapter is all about. The kinetic model is a bit of theory that you have to learn. Why? You need that theory to explain what's happening in the graphs. It explains what is happening here, that theory. Then you need these words like melting, freezing, condensation, boiling, etc., to also explain what happens in these graphs. So you're going to get a graph and they're going to ask you short questions like boiling point and point for vaporization, stuff like that. And then they want you to explain what is happening, and it's going to be like 4 marks. And then you have to explain, like we did here, what is happening in this heating curve. Each of these sections you must be able to explain, and that's going to be like between 4 and 7 marks. So you need to explain on a kinetic level what's happening there, what's happening here, what's happening there, there, and there. And I think your task is going to include that. Okay, so we have 5 minutes left. Take out a pen and paper. Please hide your stuff from your friend. You can't see it. I want you to write the following. I want you to write magnesium fluoride. I want you to write what? Let's say potassium What? Oh, sulfate. Those two, quickly. Magnesium fluoride and potassium sulfate. You only need the periodic table. I'm not testing you on the. I'm not testing you on the that little block of stuff that you still have to learn. Thirty seconds. Answer, magnesium fluoride. Anyone?
MgA.
MG?
Yeah.
Nope. Magnesium is 2 plus, fluoride 1 minus. I need another fluoride ion, so it's 2. Come. Potassium sulfate. Potassium, please. Zellner.
Okay, well, the K will be in the second group, first group, which will be plus 1 plus.
Yes.
But your sulfate, it's O. I couldn't find it on the. How would the sulfate look on the periodic table?
Sulfate.
Which is the S.
Yeah, it's sulfur. Where's my polyatomic? Just look here quickly. You have, oh, sorry, I've got the wrong word there. It's sulfide. Sorry, I wrote sulfate. That's wrong. There's SO4. Sorry, that's a mistake. My mistake. So it's sulfide. Sorry, that's wrong. It's sulfide. You have a lot of them. You have sulfide, sulfate, sulfite. Sulfide, DE at the end is always just the atoms ion. So that's my mistake, Zelna. Okay, so sulfide is in group?
Sulfide is in group 6.
So it's 2 minus.
Yes.
So
Will it then be K2S?
yes. So that was my mistake. Just look here. Potassium sulfate would have been K, and sulfate is SO4, isn't it?
Yes. and
2
then
negative.
S,
So that would be K2SO4. You're going to get sulfate a lot. It's a very important one, but we're not there yet. Okay, awesome. Have a great day. Do your work. Soon you'll get homework. Okay. Soon you'll get homework. Right. But I want you to do all your studying parts first, and then we can, once you start here with the atom, there's a lot of homework waiting. Okay. Excellent.
So what must be, if there's anything important you think you might want to learn in theory, will you tell us?
If there's anything,
Important in theory that you think we might want to learn?
yeah, it's difficult to tell you what is important in theory because I can tell you now that this kinetic model is extremely important. That I can tell you. But the thing is, the first chapter's theory, you're going to be examined on in June, and when you write exams in June and end of the year, you'll only find 2 or 3 marks max out of that. But Now, for these first tests, you might find that the test consists of 10 or 15 marks of the first chapter's theory, just because we haven't done other stuff. So it's difficult to tell you what is important now. At the end of the year, I'm going to tell you that the mixtures and homogeneous and methods of separating mixtures are not important. Don't even. But why? Because it will count only a maximum of 1 or 2 marks in the whole exam. But at the moment, it's important for you because you need to. What you need to understand is you need to rake up as much marks right at the beginning of this year, so that your year mark can be good. Start doing really well right at the beginning. I don't know what they're going to ask in the test, so I can't really tell you which parts of the theory is important for now. But kinetic model has always been important because it's a lot of marks. Right. Have a great day.
You think?
Thank you.